Hello everyone, I am Pierre Essig from Centrale Supélec in Rennes, France, and this is a joint work with colleagues from Centrale Supélec and also EDF R&D. So today I want to talk about one specific aspect of energy system optimization, which is anticipativity, and this is a quite commonly made hypothesis that you may also know as perfect foresight. And the question I want to ask is, to what extent anticipative operation can in fact impact the entire sizing optimization of microgrids or energy systems in general? To answer that question, I need to take a step back to recall that sizing an energy system, and here as an illustrative case, I have 4 components, 1 battery, 2 renewable sources, 1 generator. Sizing means finding the best ratings for these components to minimize the cost and satisfy the load. And even if I'm interested only in these 4 sizing variables, in fact, I am forced, although I like it, to also solve the energy management problem, that is, at any instant, find the optimal power flow in these components. So this energy management can be anticipative because in some models, the entire project data, like the load curves, are being used to solve this problem. So to solve this joint design and operation problem, I will argue that there are basically 2 types of models, and this is maybe a bit detailed in the poster out there. On the right, this is a typical, what I call all-in-one model, because in one algebraic model, there are the sizing variable, the energy flows as open variables, and this is solved in one program, linear or mixed integer program. So this can be solved often to global optimality, which sounds great. However, this typically suffers from anticipativity, in the sense that it's possible that at some instant, the decision to charge the battery, for example, is in fact influenced by a future event like a peak load that needs to be shaved. On the left, this is another approach like close to what like the Homer tool is doing for sizing microgrid optimization. And at the core, there is a microgrid simulator, which is embedding an energy management strategy, which is often non-anticipative. And this, for given sizing, yields the performance of the system over its lifetime. This gets iterated by a black box optimization solver, so the convergence is sometimes a bit fuzzy. This can be suboptimal, however, it is non-anticipative. So 2 very different technical implementations for microgrid sizing. So there are many technical details if you want to compare it, but at the core, the key difference is anticipativity. And does it make a difference in the end? And I will argue that yes, in some cases, it can make a difference in the sizing. So I have taken the same data for the same cost minimization with 0 load shedding, and you can see the sizing of the 4 variables using the 2 methods. And the rule-based method is giving a bigger generator than the all-in-one method, which is anticipative because it can use in parallel the generator and the battery to shave some future load peak. For the renewables, the sizing is quite the same. Now, is it a problem to have a smaller generator? And in fact, the question is what happens on the field in the real-life performance. So I take these 2 sizing in the same performance operation simulator, so using the same rule-based non-anticipative rule. And in fact, with this undersized generator, I get some load shedding, so it does not satisfy the expected performance. So I will conclude that in some cases it is something to watch for. Anticipative methods are typically in principle global optimum, but in fact on the field, when the future cannot be forecasted, it can give some bad surprises. So one last word about the tools that are being used. The simulator for microgrids, it's like a baby Homer tool, is already published. The algebraic model for the comparison is really a draft state, so it's to be published. It's based on JUMP, like the previous speaker mentioned. And one specific aspect I want to mention, to make the good comparison, I had to implement the effect of storage cycling aging on the annualized cost in a convex fashion. So if you find this interesting, we can discuss later on. Thank you.